Hello and welcome to Lesson 4 of the Python Crash Course. My name is Sam and today we will be talking about conditional statements. To start off with, let's talk about why we need conditional statements. The purpose of conditional statements is to help direct the behavior of a program based on a certain condition that can be evaluated to true or false. For example, say that it was 7 p.m. and we were deciding between studying for our exam based on whether we needed to or not. If we needed to study, then we would open our flashcard app and start doing flashcards. Otherwise, if we didn't need to study, we would go do something else. Our studying example is a great example of both why we use conditionals and the structure of conditionals. We use conditionals to determine what behavior our program should undertake. In our example, we wouldn't want to study even if we didn't need to. The structure of conditionals is based off the if-then-else paradigm. If we needed to study, then we will study. Else, we will not study. The figure on the bottom right here shows this structure in a visual format. If the condition that we are testing is true, we will do something. If it is false, we will do something else. Python and other programming languages make using conditionals easy. There are three keywords that will be used when using conditional statements. The first is if. If a condition is met, then we will do something. The second keyword is elif. If the first condition was not met and this new condition is met, then we will do something. Finally, the else keyword functions as a catch-all. If all the preceding conditions were not met, then we will do something. Alright, let's go ahead and get started. So I created a new PyCharm project. I'm going to go ahead and delete all this sample code. We're almost at the lesson where we're going to start using that, but just bear with me for now. We're still going to delete that. Let's go ahead and add in our comments. Okay, so to start off with, let's do a basic if statement. So if true, let's print this is true. And now I'm going to go ahead and run it, and you're going to notice that I got this is true. So the reason that I'm using this example is we always know this condition is getting met because it's true. But I wanted to show you the way that these conditionals work. So we have our keyword here, if, and then next to it we're going to have a conditional. If this conditional evaluates to true, then we are going to execute this line of code. Please note that we have indented from our original part of our code. Now, a lot of students that I've worked with have difficulty kind of understanding why we indent and seeing how it relates when we write Python code. Indentation is important because it tells Python that this block of code in line number 5 belongs to this code segment from line 4. So basically, when Python is reading this, it will hit this if statement and be like, if this condition is met, then we are going to execute these lines of code. And it knows that these lines of code need to be executed because of the fact that they're indented to be underneath this if statement. If we had a statement out here where it's on the same indentation level as this original if statement, this code will be executed regardless of the condition of the if statement. Let's do an example just to show that. So I'm going to set if false, which we know is always going to evaluate to false, right? So conditionals uses true or false, and so if I say if false, then we know that we're always going to skip this line of code. We're going to skip whatever we're supposed to do here. Well, always. All right, so if I go ahead and run this, notice that I'm getting this will always evaluate, but I'm not getting this is true. So again, take a minute, try to process that. I'm going to cover it one more time. Just think about it, and why do you think this happened? And so I hope you know that it happened because this block of code here, or this statement, does not belong to this if statement. So this if statement is only in charge of the elements that are indented underneath it. So for instance, if I add in another one here, this is a great tutorial, and I change this to true, we're going to notice that we're going to print all three of these. Whoops, I accidentally put a breakpoint. And so notice, yeah, so we actually got all three of these. But if I change this to false, I'm going to end up only getting this will always evaluate. Now notice we can nest ifs in our statement, and so we would indent even further. So if we go if true, print further indented. So now what would happen when it's happening in this code is if this condition is met, we will do these two things, and then we'll check this condition, and then if this condition is met, we will do this last thing. And so in this way, notice that this print statement here on line number 8 is indented twice as much as compared to these other ones. Because what this statement is basically saying by this indentation is that this print statement belongs to this if statement on line number 7, which then belongs to this if statement on line number 4. And so that's a little brief introduction to indentation, and I hope that made a little bit of sense. I think you got the basic idea of if statements here with our true or false. And so now let's go ahead and run into some examples using actual numbers or actual values instead of just true or false, right? So we in our programs we're never going to write if true, because what's the point of doing the if statement if you always know it's going to be true? So we're always going to be checking some condition to see if it's true or not, and then based on that condition, based on that result, we're going to execute some code. So let's do some examples with integers. So I'm going to say my int1 is going to equal 10, and my int2 is going to equal 20. Now notice you can do these conditionals with any data type that we talked about, in our previous tutorial. So if you haven't got a chance to check that out, please do so. But depending on your data type, you're always going to be able to do some conditions where some comparisons that you might not be able to do in other data types. So with integers, we can compare whether they're equal to, greater than, or less than. So let's do an example where we compare if they are if one is greater than the other. So if my int is greater than my int2, we're going to do a print my int. And one thing I guess I forgot to mention is that whenever we do these if statements, we have to put a colon here at the end. And what this colon basically is telling Python is that this is starting a block of code, right? It's going to start an indentation block. And so Python's going to be expecting that you're going to have a line of code indented that needs to be executed here. We'll see these again when we're doing functions and loops later on in our next tutorials. So yeah, just keep in mind that you always need to put that colon at the end of your if statements. So let's go ahead and check if my int is greater than my int2. And so before we run it, what do you think is going to happen? I'll say my int1, or let's actually just do is greater than my int2. So if we go ahead and run it, So notice that we didn't get anything. No results, because my int1 is actually not greater than my int2. So let's actually add in our next keyword, which is else. Else, if you remember from our PowerPoint presentation, is basically saying if this condition is not met, then we are going to execute something else. So we're going to go ahead and just copy, and then we'll say is not greater than my int2. So we go ahead and run this. We notice that we get this else statement. So this is always evaluate because it's not as part of an if statement. We also are going to end up getting this else statement, this else block to execute since this condition was not met. All right, that's great. So let's try it using the less than sign. So let's change this to is less than, is not less than. Oh. And so which one do you think is going to execute? And now notice, I hope you said that line 15 was going to execute and not line 17, because you notice that my int 1 is less than my int 2. All right. And so again, you also, I don't know, this might be another misconception is that you don't always need to have variables here. You can put in, if I wanted to do my int is less than 2, I could do that, right? It's not less than, well, I said 20, but I'm using variables here for simplicity's sake. All right. You can also put in an equal sign after each of the operators, so that's less than or equal to or greater than or equal to, and that will, do less than and equal to or greater than or equal to, depending on your sign. Now, the last operator that we need to talk about is the double equals operator. And so double equals is a very important operator because it checks to see if two variables are equal to each other, or the two sides of the equation are equal to each other. So what this is asking is, if my int 1 is equal to my int 2, then we're going to print some stuff out. So we'll say is equal, is not equal. And so let's go ahead and make them equal just for fun. Oh, I put equal, whoops. And we go ahead and make them equal. We see 10 is equal to 10. Now, notice that we have a double equals here instead of a single equals. So this is a very important thing in computer science that I think a lot of people, when they're starting off, get confused with, is one equal sign is assignment. So we're assigning 10 to this variable. Two equal sign is comparison. We're comparing two variables against each other. Yeah, so make sure you don't get confused with that. And remember that when you're doing comparison, you're going to use two equal signs. When you're doing assignment, you're only going to use one equal sign. All right, so the next part we're going to do is we're going to work with strings and lists. And so remember, in our variables tutorial, we talked about how strings and lists are very similar in the way that they're structured. So strings are basically just our lists of characters, while lists are lists of whatever you want them to be. And so the reason that's important is because the way that we can work with both strings and lists are going to be very similar between the two. So I'm only going to be working with strings for now, but I want you to recognize that a lot of the operators I'm going to be talking about now are also usable with with lists. So let's define a string. My string 1 is hello world, the good old hello world. And then let's set up a if statement that checks if my string 1 is equal to hello world. So we go ahead and do this. So I want you to think about what's going to happen here if I execute this code. Let's see. And so notice that we get is equal because we're saying that this string is equal to this string here. Pretty simple. You can also use greater than or less than with strings. I think it gets a little confusing, so I personally don't use them very much. But please note that you can use greater than or less than with strings to perform certain operations. Now the second operator that I want to talk to you about with strings and lists is the in operator. And so the in operator is basically saying is something in something else. So if I do this, what do you think is going to happen? Let's go ahead and see. Notice we don't get anything because what this is basically saying is my string, and if we can replace my string 1 with hello world since it's just storing hello world. So it's saying if hello world in H. Now does that make any sense to you? Can you go up to somebody and be like, hey, is hello world in H? That doesn't really make a whole lot of sense, right? So and that for that reason, it's false. It's not in H. Let's say in string here. Now, on the other hand, if we change this around, we say is if H is in hello world or my string, we're going to get in string. So notice how H is a character in hello world, and that is in my string. So we're going to go ahead and print in string. Now, we can do multiple things. So we can say HE in my string, and you'll see that that's also the in string. We can do space W in my string, and that's also in string. I don't think we can do space W space, that is not in my string. But that inner operator is really useful, especially when you're working with lists, to find if something is in the list or not. And so that gives you another use case of conditionals and how to use conditionals there. Now the last thing that I want to talk to you about is using compound conditions. So when I say a compound condition, I mean there's two conditions that need to be met in order for us to move on with our code, right? So let's say we have, I'm going to recopy my ints here just so that I can scroll down and you can still see them both. So we'll call this my int1, my int2. We'll change my int1 to 30, my int2 to 20, and then we'll say my int3 is equal to 10. So here what we're going to do is we're going to say if my int1 is greater than my int2 and my int3 is less than my int, or actually let's keep my int1 on the left hand side. My int1 is greater than my int3. We're gonna print my 1 is the greatest. All right. And so notice we have 30 is the greatest. Now let's go ahead and change this so that we know that this is not going to evaluate to true. But let's add in a new condition called the Alif Condition. And again, we talked about this earlier, but Alif is basically saying else if that first condition is not met and if this condition is met, then we are going to execute some code. So Alif, my int1 is greater than my int2 and my int1 is greater than my int3. We're going to once again say my int1 is the greatest, but here we're going to change this to is not the greatest. You know, in retrospect, I probably could have done a better job with setting up these examples, but it works for now. And so we can see here that we're getting 30 is the greatest. So this first condition is not met. So my int1, which is 30, is greater than my int2. That's 20, so that's true. And my int1, 30, is not greater than my int3, so that's false. So this condition is, so what this works out to be is this part is true and this part is false, which equals, remember we're using 2 for, what I'll do is I'll use this, which is equal to false. Because what and is saying is both conditions need to be met in order for this condition to pass. And so therefore you're not able to execute this line of code here. We have to go to this next line of code here and then move forward. Now let's say we go ahead and change this to a negative sign and say it's not the greatest. It's not the greatest, part 2. Oops. And we can say else print we need to do some checking as to what is the greatest. So now you can see that if this condition is met, then do this. Else, if that first condition is not met and this if condition is met, then we'll do this. And then else we will do this. Now note that we don't need this and here in either of these clauses. We can just do elif my int1 is greater than 2 or something, and this will work perfectly fine. It's just a condition that we're going to set up here for elif. So don't get too confused with that. I know I used elif and in the same example, but I think you guys can handle it. And so the last compound clause that we're going to use is the or clause. And what or is saying is if this one condition is met or this other condition is met, then we will do something. So let's say if my int1 is equal to 20 or my int1 is equal to 30, we're going to say print equal to either 20 or 30. Okay, so even though my int, we know my int is 30, so it's not equal to 20 for sure, so this will evaluate to false, but it is equal to 30, so this should evaluate to true. So therefore, this statement should print out, and we know that we see it right here that we are getting that statement to print out. Anyway, I hope you enjoyed this tutorial. That brings us to the end of this video. Please join us next time as we talk about loops.